Hello friends, hope you are safe at your place and stay home, stay safe. So in the series of design of machine elements second, which is a third year mechanical engineering 6M curriculum subject of Rajasthan Technical University. In the last session we have discussed about the introduction, what are the books we have to refer. So as of now I am referring this TMH book of Professor B.B. Bhandari. Okay, and in the last session we have covered about the stress concentration, as you can see if I will scroll up. So we have touched a few numericals as well. I have also given you the assignment to complete this numerical and just answer or write down in the comment box of this particular video. Okay, so that you can see here. So this is the solution of this particular numerical in the last session we have discussed. So today we are going to discuss about the fluctuating stresses, or you can say what are the different kinds of alternative stresses. Okay, so the fluctuating stresses are of various three kinds of cyclic stresses you will study. First is fluctuating or alternating, I will say. Second is repeated, and third is reverse. So I will explain this with the graph, which will be very easy to understand if you will go to the pictures given in the book. So in the repeated stresses, it will start from this point, okay, at sigma m, and again it will come to the zero, okay, and again it will go to the peak and come to the bottom. Means the maximum stress will be sigma a, while the minimum will be 0. Okay, sigma max will be sigma a and sigma min will be 0. While here in the fluctuating stresses you will also find sigma a, which will be equals to sigma min plus sigma a. Okay, and sigma min will be, or minimum stresses will be equals to sigma m. Okay, so there are two stresses which are sigma a and sigma m, as you can see in the picture, which are called as mean stress and amplitude stresses. So sigma mean, or I will say sigma m, can be calculated as 1 by 2 sigma max plus sigma min. Sigma a is 1 by 2 sigma max minus sigma min. With the help of this you can calculate the vice versa equation. If sigma m and a is given, then you can calculate sigma max and min. If max and min are given, then you can calculate sigma mean and sigma amplitude or stress amplitude. So in this way you can differentiate that it will start, or the picture will look like this, then it will come under fluctuating stresses. While in the reverse stresses, like as you used to see the diagram of sine waves, so this will be equals to the picture of reverse stresses. So basically there are three types of cyclic stresses you have to understand, and we are going to study more about the fluctuating. So what do you understand by the fatigue failure? Fatigue, when you just encounter or apply the reverse load on one wire, so that you should not use any kind of cutter or any other tool. So you just apply the reverse load for n number of cycles, then ultimately it will break, as you can see in the picture. Like there is a straight wire, if you will apply the load P1 from top and P2 from the bottom and apply it for the n number of times, then definitely it will fail, or it will broke down because of the fatigue. Okay, so that's why fatigue failure is defined as a time delayed fracture under the cyclic loading. Example of the parts in which fatigue failure are common, like transmission shaft, connecting rod, gears, vehicle suspension, spring. So this is very common. They are having some cyclic loading, or we can say some alternating or cyclic stresses are applied on these particular parts, so it will fail very easily. Okay, and cracks are likely to occur in the following region, like region of discontinuity if there are any discontinuity, region of irregularity if there are any irregularity, or internal cracks. Okay, if internal cracks are there, so these are the areas, or I will say these are the areas of stress concentration where fatigue failure will easily occur, or fatigue failure will easily happen. So you can also encounter this kind of thing. And there are two distinct areas of fatigue failure, which are region indicating slow growth of crack with a fine fibrous appearance. Fine fibrous means a small wire kind of appearance will be there, and region for sudden fracture with a coarse granular appearance. Okay, so these are the two distinct areas of fatigue failure. Now we came to here, which is called as endurance limit. So what do you understand by this endurance limit? Basically endurance limit, or I will say fatigue limit of a material, is defined as a maximum amplitude of completed reverse stress that the standard specimen can sustain for an unlimited number of cyclic without fatigue failure. Okay, means ultimately if you are going to calculate the value of your fatigue failure, okay, or I will say the for endurance limit, then this is nothing but the capacity of that particular material to sustain that unlimited number of cycles without any kind of failure. Okay, while the fatigue life is defined as number of stress cycle that standard specimen can complete, means whatever the number of cycles will be there on which it will going to fail. Okay, or you can say that standard specimen can complete during the test before appearance of first fatigue crack. Okay, so before first fatigue crack, whatever number of cycles has been sustained by the material, that is called as fatigue life. Okay, so I'm stopping here. You can also go through this particular test which is called as rotating beam in fatigue testing machine. This is fatigue testing machine where you have to check the fatigue limit, or I will say number of fatigue cycles or fatigue life of that particular material by applying the specimen over here electric motor and revolution counter to calculate, to count the number of revolutions or number of cycle. So in this way you have to go through this particular rotating beam fatigue testing machine, which is the assignment for your particular this topic or today's talk, so that whenever in the university exam they may ask that how you can explain or give us the practical exposure or practical guidelines for calculation of number of fatigue failure, number of fatigue cycles. So you can go through this rotating beam fatigue testing machine. As of now I'm stopping here, so we'll come with the next topic of this syllabus. Thank you so much, and stay tuned with Engineering College Banswara YouTube channel for more such updates about different branches of engineering like mechanical, civil, electrical and computer science engineering. Okay, so if you have any doubt, do write in the comment box of this particular video, and meanwhile just go through all the topics or whatever content we have covered. This is all, and reference is there from BB Bhandari book of machine design. Okay, thank you so much.